So why not auto-tuning? So as you know, it is something very popular in the market now called auto-tuning. So a lot of servo motors and for example, some robots, they come with a feature called auto-tuning. What is auto-tuning? Auto-tuning is that rather than a person sit there and, for example, tune the parameters for the PID, the system itself, for example, he has this feature, you press a button, he measures some parameters, he shakes the system a little bit, and after that tune the system by itself. So why still there is a demand for people they know tuning, okay, and you cannot rely on the auto tuning itself. So the first reason, okay, manually tuned PID is overperform auto tuning most of the time. So if you know what you're doing, this is very important. If you know what you are doing, okay, even that you really understand PID, they grasp the concept very well, and you tune the thing, you can achieve a better tuning than auto tuning. So you may ask yourself why. So the technology is so advanced and so on and so forth. Still, we cannot because we have all these features and this and that, right? So they have to be able to tune. It is not about the limitation of computers. So the reason that they do the auto tuning, it underperform, for example, a normal tuning, is that in the real application, for example, all these vendors, okay, so they want to give something robust, and they have to supply this algorithm that tune the PID to wide range of application. They don't know who is the end customer. The end customer can be somebody in, for example, mining system. Okay, another guy is in semicon. Another guy could be the application. The end application could be anything. So what will happen is this. So these guys, they cannot to go aggressive with their tuning, because if, for example, imagine, for example, robotic applications is not a safe thing. Okay? If you think that the robotic is something safe, and for example you are very happy ending, for example, 9 to 5 job, and you would have a very easy life doing robotic application, this is not okay. Robotic is it is often, it could be a dangerous job. Okay, so I don't want to freak you out, but it could be a dangerous job, and you can screw things up, for example, your mistake can even kill people. So you cannot take your chances. Okay, so this is the reason why that all these manufacturers that they supply auto tuning, okay, they don't want to take their chances to go too aggressive and use all the power that your servo drive provides. Because why? If they used all the power, for example, what if something goes wrong? Okay, what if the algorithm, they want to play it safe? So that is the reason that the auto tuning algorithm, it does not give you the best performance out of the system. Most of the times it gives you the best the most robust thing, okay, the safe robust thing that, okay, it cannot go wrong. So it gives you something that behave, okay. But sometimes in some application, especially I come from Semicon, okay, you don't want the thing behave, you want the thing perform. In Semicon, every IC that they produce, it's the boss that is standing there, he said that money, okay. So everything counts, okay, every cent, every second, it counts, okay. So this is the reason why you want to take the entire power out of that motor, okay. You want to sometimes, the margin that you have to overperform the motor is a little bit, okay? So it is almost, you are taking all the power out of 99% of the power out of the motor, okay, continuous power out of the motor, okay. So this is the reason why that still there is a demand for people that they can do the tuning, okay. So, and the auto tuning they cannot do. This is the first reason. Another reason that it is that auto tuning, although it works most of the times, okay, but still some applications they cannot do auto tuning. So one of the things that you need to do for auto tuning, they call it shaking, okay. So what they do is that they shake the motor for example for a little bit, and after they're shaking the motor, okay, what they do is that based on shaking the motor a little bit, they will, for example, determine all the parameters and so on and so forth, and based on those parameters, they will set your tuning parameter. But for example, in some, I won't say in all, but in some vertical application, you don't have even the possibility to, for example, shake the thing. Okay, you make the servo loose. Okay, if you make the servo loose, for example, imagine something like a free lift. So for example, if you let the system loose, okay, and for example you remove the brakes, and after that let the, for example, the lift move freely, what will happen? The lift will fall down, right? So you cannot run something like a body plot when you are, for example, in some vertical applications. Okay, in many vertical applications, still maybe possible to run there, for example, auto tuning. But in some applications, it's not even possible to do auto tuning. This is the reason why you need to know PID, and PID can be your superpower. So before we conclude this session, so just I want to tell you, I talk a lot about PID, why it is good and this kind of thing. But I want to tell you what is the PID also. Okay? So after all this talking and this kind of thing, okay, what is PID itself? So to put it in short, okay, what PID say is that if you know the error, current error, and you know the history of the errors, and if you can predict the future of the error, you have a good chance to control the system. This is all the things. If you want to know what is the PID only, okay, so this is a pretty good explanation. You don't need to see the entire course. But if you want to know that how the entire PID works and how everything is put together, okay, please watch the entire course. Thank you.